So this is the video that explains stoichiometry, and we're going to do this briefly with the sandwich example, and then we're going to continue. So first we will define our limiting reagent, which is the reactant or reagent that is completely used up in a chemical reaction. So this is the reagent that after the reaction's over is completely gone, and our excess reagent is the reagent or reactant that is left over, or excess basically, you can just use the term, after a reaction is complete. By complete, I mean the limiting reagent has been completely used up, so the reaction cannot go on anymore. And for this, we will pretend that our equation that we're working with is a sandwich making equation. So we're going to need 2 slices of bread, 3 slices of meat, and let's say we're going to use another 2 slices of lettuce, and all of this is going to give us 1 sandwich. So let's just assume that this is how we make a sandwich. Just to make this a bit different, let me use 1 slice of lettuce instead of 2. Okay, so this is our recipe for a sandwich, and this equivalent is given by a balanced chemical equation. And you will note that I use the word slices everywhere, so 3 slices, 3 slices, 1 slice of lettuce. If I had an entire lettuce plant, that would be like different. If I had a entire loaf of bread, that would be different. So we have to pay attention to the units here, and we're doing everything for this example in units of slices. So we will write our equation on top here. So 2 bread plus 3 meat plus 1 lettuce gives us 1 sandwich. And let's say I open my fridge in the morning and I find 8 slices of bread, I find 6 slices of meat, I find 3 slices of lettuce, and the question is, how many sandwiches can I make? So this is, in essence, what the stoichiometry questions are going to be like. And you will note that I can kind of figure out, you can look at this intuitively, and you might be able to tell me that I can make 2 sandwiches. Because after I make 2 sandwiches, my meat's going to run out, and I can't make any more sandwiches with, plus 3 lettuce. This shouldn't be an S. 3 lettuce. I can't make any more sandwiches because I don't have any more meat, right? You could argue in this case that you could make a sandwich with just bread and lettuce, but that doesn't really work in a chemical reaction. You can't miss an ingredient and still continue with the reaction. So we're going to assume we need all these 3 things in this exact ratio to make a sandwich. So again, you could tell me that the answer is probably 2 sandwiches because I have 6 meat, 3 meat here. And the way that we're going to do this is use the method of what is called least moles, and this involves like multiple steps, so we are going to pay attention very carefully to all the steps that we're doing. Because for example, if I had a lot of bread, let's say 2 slices of bread plus 386 slices of meat plus 125 slices of lettuce, I'd like to figure out how many sandwiches I can make, right? So what we're going to do, again, we're going to first divide, so just with 252 slices of bread, how many sandwiches can I make? I can make 252 divided by 2, right? Because I need 2 slices of bread for each sandwich. So just ignoring these 2 ingredients, ignoring the other 2 ingredients, just with my bread, I can make 126 sandwiches, right? So we're going to do that. 386 slices of meat. Just using the meat, how many sandwiches can I make? I can make 100 128 sandwiches, I think. 386 divided by 3 is 122.6. Oh, I lied. Oh, 386. 128.6. So we'll round that to 128 sandwiches because I can't have 0.6 of a sandwich. And then 125 lettuce. Okay, I shouldn't have done that. That was my bad. I can have 0.6 of a sandwich, let's assume. So let's say I do have to keep all my decimal points in actual calculations, of course. And divided by 1 lettuce per sandwich would give me 125 sandwiches. So this is basically where you stop and say, okay, this is my least number. So when I start making my sandwiches, my lettuce is going to run out before my bread or my meat does, and therefore this is what is called the limiting reagent. I can make 125 sandwiches, but when I start my 126th, it doesn't have lettuce in it because I only had 125 slices of lettuce, I should say. So the answer now would be to do 1 lettuce is going to give us 1 sandwich, and therefore 125 slices of lettuce gives us 125 sandwiches. So I write 125 sandwiches. This is my limiting reagent, and we'll do the excess calculations a bit later. So we're not going to worry ourselves with that at this point in time. Okay, so question number 3, I think. We're not doing question number 3 over here. We're going to jump to some actual chemical equations. And instead of using slices, we have to use moles. So that's going to be very important for us moving forward because we have to be sure to use moles in our calculation. So the first couple of questions that we'll be doing only involve moles, and then we'll be moving to some harder looking questions. So let's say I have 2 moles of N2 and 7 moles of hydrogen, and this is basically the reaction that I am doing. So in this video, we're just going to go over the moles, and then we'll get to the mass calculations a bit later. We have to do some mass-to-mass problems. But yeah, we'll do that later. Now we're just going to stick where the question is given to us already in moles. Okay, so again, this is giving us the ratio. So 1 mole of nitrogen combines with 3 moles of hydrogen to give us 2 moles of ammonia, right? So now, again, 2 moles of nitrogen, I do 2 divided by the 1 here. This would hypothetically give us 2 moles of NH3. Well, technically, we don't want to write what this is here because it would give us 4 moles of NH3. But we're just going to stick with 2 and not write what comes after that. And then the 7 moles divided by the 3 gives us 2.33. So we're going to use the method of least moles after we have divided by the coefficient. It's important to remember that we can't just compare the 2 and the 7 here. We have to compare 2 and then 2.33 because we have to divide by what this is. Because each reaction or each unit basically needs only 1 mole of nitrogen but 3 moles of hydrogen. So even though you have more moles of hydrogen to start with, you might not end up having the right amount left over, or the correct limiting reagent. So now you look at which one's lesser, the 2 or the 2.33, and we decide that 2 is lesser. So this is our limiting reagent. So our limiting reagent, or LR, is nitrogen, right? So now we have to, with our limiting reagent, all the calculations after this we'll be doing with our limiting reagent. So we know that 1 mole of nitrogen produces 2 moles of ammonia, or NH3. So we have here, don't look there, we have here 2 moles of nitrogen. So that will produce 4 moles of NH3. Essentially because this is essentially doubled, So this also has to be doubled. You can basically think of it that way. 1 times 2 gives 2, 2 times 2 gives 4. And this is 4 moles of ammonia. And we have to do the same calculation to find out how much reactants are left over. So 1 mole of nitrogen reacts with, or requires 3 moles of hydrogen. Again, we get the first statement that we're writing always from our balanced equation. And then we have 2 moles of nitrogen. Again, I had to multiply by 3, so I'm going to multiply by 3 to get 6 moles of nitrogen. Oh, sorry, hydrogen. Right, and I had 7 moles of hydrogen, so what is left over is 7 minus 6 is 1 mole of hydrogen will be left over at the end of my reaction. So this is how I solve pretty much all the questions that I'm doing. It's 3 steps. I have to find my limiting reagent here, and using the limiting reagent I do 2 calculations. Let's try one more. So 5 moles N2, again, to find my least moles, I have to divide by the coefficients up top. So I do 5 divided by 1 is 5, and 12 divided by 3 is 4. And then I look at these numbers and decide which one is least. So I decide 4 is least, so hydrogen here is my limiting reagent in this case. So my limiting reagent is hydrogen. And then I do the exact same calculation I did here. So I know 3 moles of hydrogen gives me 2 moles of ammonia of my product, because I got this from my balanced equation. 3 gives me 2. Now I have 12 moles of hydrogen. So to get from 3 to 2, basically I had to divide by 3 and then multiply by 2. So I'm going to do the same thing. I'm going to do 12 divided by 3 multiplied by 2. And you can see the pattern here. You start with this, you always multiply by whatever's on top and divide by the diagonal. And we'll talk about that also. We'll do a lot of practice with this so you get the hang of that. And this is essentially 8 moles of ammonia is produced. So we have found how much product is produced. And we do the same calculation. So 3 moles of hydrogen required 1 mole of nitrogen. I have 12 moles of hydrogen. And this is divided by 3, so I also have to divide by 3. That requires 4 moles of nitrogen, but I had 5, so my excess was 5 minus 4 equals 1 mole of nitrogen left over, is my answer. And I trust you can do that one. For practice, the answer keys will be posted soon, and I will see everybody in class.